Hello engineers, this is Mr. Hernandez, and in this video we're going to be going over the next unit in our electronics section, which is all about microcontrollers. So in this presentation, anything that's in red is something that's important, something that could be on the quiz. So if you have a notebook out, you should be writing those down. Remember, you can pause at the end of each slide in order to finish writing those down, because I'm going to go through a little bit fast here. But let's go ahead and get started here. First, definitions. A microcontroller is a small, specialized computer that lives on a single chip. And because they are so small and specialized, they can't do everything that a full-size computer like a laptop or even a cell phone can do. But because they are small, we can leave out the parts that we don't need, and we can add things that we can use, like special connections, special ways to communicate with other things. And so microcontrollers are going to be our bridge between programming, which lives on a computer, and hardware, so things in the real world like motors and lights and other things. So that's the basic definition of a microcontroller. Remember to write this down since it is in red, and then we can go ahead and move on. So what is a microcontroller going to be used for? Well, there's two basic categories here. So first is prototyping. If you are trying to work on an idea, you can use a microcontroller to help you test things out with electronics. This is where a microcontroller would kind of live on the desk. You can connect things to it, change the programming, and keep on working on things until you get it right. Now, if you are done with the prototyping though, if you're ready to actually test this or keep this final product, then we can take the microcontroller and make it embedded, which means that you're no longer going to be able to access the microcontroller from the outside. You can't really change the programming anymore, but it's just going to live inside of another component. You can think of an embedded system as adding computers to something else. For example, our 3D printers have a microcontroller on board, and the only thing that microcontroller does is connect to the motors, move them around, and keep the 3D printer working. It can't go online, it can't check your email, but it can do its job. It can run the 3D printer. So let's go ahead and move on from microcontroller uses to our specifics. So we are going to be using a microcontroller called an Arduino Uno, because this is the most popular microcontroller. So all the skills that you guys learn for this will be able to be used in future high school and college classes. I actually used an Arduino Uno in a college level class. So I know that it's something that's actually practical for the future. Just a little history lesson on this. Arduino is actually an Italian company, and they designed these open source microcontroller boards. That means that they design and they also make the board itself, the physical computer. But because it's open source, that means that anybody can take the same design and use it and modify it. This isn't going to be on your test. This is just something that's important to code. A lot of programming is open source so that programmers can share their solutions with each other. So that's just a little history lesson there. And it's also going to explain something on the next slide. So this is the physical board that we have at LMS. You can see it says Uno on it right here, but it doesn't say Arduino. It's because it's not made by Arduino. It's made by another company that took the open source design and built it. All right, enough history. I'm going to go over the hardware here. And keep in mind, even though you guys aren't going to get these this semester because distance learning, you will be able to do this in a simulator online, and it replicates all the features. So starting from left to right, we've got a USB port to connect to the computer. We've got a power plug so we can give this some power. We've got some connections over here called pins, these little squares right here. So these in this section are for power, so they can send out, it's hard to see the labels, but this one's 5 volts, this one's 3.3 volts, and this one's ground. We've got a few of those here. And then to communicate with other things, we've got the input-output pins over here. And on this whole board, a lot of this is actually just to give you guys extra room to connect things. The actual computer, the microcontroller itself, is this rectangle right here. This is all the smarts on the board. These are just ways to connect them to make it a little bit easier. Alright, so let's go ahead and look at those connections. So this is the information from the last page just written out. So the USB port communicates with a computer and can carry power. The power plug just powers it. So if you've already got it programmed, you can just plug it in and it'll run that program. No need to have the computer involved at all. And last, we've got digital input-output pins. That's what I/O means. And those pins are going to connect to other devices. And that can be pretty much any electronic device that you guys have seen in Tinkercad and that we actually have in the engineering lab as well. So that's the Arduino connections, that's the hardware. So now we're going to take a look at coding. So coding or programming is the way that humans and machines can communicate to each other. So computer code is like a whole new language that people made up so that we could tell computers exactly what we needed to do. So let's go ahead and look at some examples of this. This is how coding used to be done. It used to be done with something called punch cards, where you'd actually have to punch holes in a sheet of paper and feed it into a computer to give it the information. This person right here is actually a pretty famous computer scientist named Margaret Hamilton. She wrote the code that ran the rocket for the Apollo space missions back in the 1960s, and those were the rockets that actually took people to the moon. And you can see, like, the physical code takes up so much room. Every page of these binders is a sheet of programming. You can imagine just how long that would take. So let's look at kind of the current day. So now software engineers can use languages that are actually written out close to English, using actual words typed into a computer, so you don't have to punch holes in things anymore. And just like languages, there's lots of different variations. So some examples are Python, C, C++, Go, and Swift. Those are all just different types of programming languages. But we're not going to be using those. We're going to be using block-based coding, which allows you to write code without worrying about the syntax. You basically don't need to worry about the grammar or the spelling because it translates the code into blocks and you just assemble those blocks together. It makes it a lot easier. It makes it harder to make mistakes. At this point, you might have used LEGO Mindstorms in 6th grade, VexIQ in 7th grade, and now we're going to be learning block-based coding for Arduino. So now we're going to go ahead and look at examples of how each program works. So starting on the left, this is a punch card, and here the top is the message that's being shown. So it says, I would like to say thanks, and then down here is the actual punches that had to be made in order to send that message to the computer. So every one of these rectangles is a hole that was physically punched out. In the middle, we have a modern programming language. So here you can see it's typed out. There's some like English words that you can recognize, like using, main, for. But here, it's not like English. Every one of those is actually a specific command for the computer. And then the last example is what you guys are going to be doing, which is blocks. So each block here does a specific thing, but you don't have to worry about like typing it out like this. Because if you missed even a single semicolon in this line, the whole program would not work. Over here, it's a lot harder to mess up. And let's look at what this program actually does. So starting from top to bottom, it first sets an LED to high, which means it turns it on. Then it waits 1 second. Then it sets that LED to low, which means it turns it off. and then it waits 1 second. So altogether, this is going to cause an LED to blink. On, off, on, off. And that's that. So you guys can see how block-based coding is a little bit easier. Alright, so that wraps up the lesson for this week. So make sure that you took good notes and go ahead and take that quiz.